Welcome at the lecture on consciousness and the brain. When I read the reviews of his latest book of Cyriel Pennartz, The Code van Bewustzijn, The Code of Consciousness, a book written in Dutch, of course, he made me very curious. So I invited him to come and speak in Maastricht, and I was really looking forward to meeting him in Maastricht, in the hall, of course, and have an interesting discussion after the lecture with you, the audience. Unfortunately, the university is still closed for education till the end of the month, and Stream Generale is following the theaters and movie theaters and in that line they are still closed, so our activities are all online. But happy that about 200 people are joining us tonight to follow this online lecture. Cyriel Pennartz will talk about an hour, after which we take a very short break of 2-3 minutes to get a drink or maybe go to the toilet, but also to look at the Q&A. I want to ask you to ask your questions about the lecture in the Q&A. Others can also read those questions, and you can upvote the questions that you like or that you want to ask yourself. And those with the most thumbs up, they go to the top and we get to them first, and maybe sometimes we don't get all the way to the end. So be sure also to upvote those questions. On consciousness and the brain, I had a nice biography, short biography, but now my screen is dead, to introduce you, Cyriel. In 2003, he was appointed a full professor in cognitive and system neuroscience at the University of Amsterdam, where he currently leads the cognitive and system neuroscience group. He merges experimental neuroscience, computational models of brain function and theory on perception, memory, and consciousness. His work in experimental neuroscience is paired with technological innovations in multi-area electrophysiology, pharmacological, and optogenetic interventions. Some words there in your bio. Advanced data analytics and computer simulations. Chief characteristics of his works are its multidisciplinary and integrative approach in which theory and computer models drive in-depth experimentation. Recently, his work has been ramifying into the clinical domain, studying disorders of consciousness and memory, and into neurotechnology, developing new methods to combat consequences of stroke. Now, that's a very nice bio and very interesting, because you are indeed very interdisciplinary and combine so many things. So I'm very looking forward to this lecture. Welcome, Cyriel Pennartz.
Yeah, thank you, Rob, and thanks very much for your invitation. Very honored and pleased to speak before you. I regret, of course, like yourself, that we have to do this online. Would have liked to come to Maastricht, a city which I love, and well, I have family there, friends, and many colleagues, but maybe another time. The first slide is also to highlight the contributions from the research group, Cognitive and Systems Neuroscience at the UVA. This was from a recent Christmas borrel drinks with pub quiz, so everybody had a good time, but you get an impression of all the young researchers contributing to the research I'll talk about. And indeed, this is about consciousness in the brain, so it has a bit of neuroscience, but also psychology and computer work, as well as philosophy. Let me start right away with the overview of the lecture tonight. I'll first pay some attention to a definition of consciousness. What is it? What do we mean with it? Then I would like to go on with peeling off more or less the brain and see what is necessary for consciousness, which cognitive capacities are important but could be missed for it. Does consciousness have a function there? Is it good for anything? or is it just there as perhaps an epiphenomenon, whereas the neurons in your brain are doing the real work? Then a little bit about computer models of perception, and finally a bit of philosophy on the nature of the relationship between consciousness and the brain. I took it from Rob that you can post questions in the Q&A, so I'll be happy to take them afterwards. But if something is really unclear, then you could relay it to Rob or raise your hand. First of all, a brief question to you for the Zoom poll. What is your background actually? I was curious to know if A, you're from neuroscience, or B, from psychology or perhaps medicine, C, from other sciences or humanities, literature, philosophy, etc., or D, from another background, other training or profession. So maybe we can take the poll. It's rapidly changing. We see quite a few people from psychology and medicine, or medicine, quite a few from other sciences and humanities, and quite a few from other trainings or professions than one of the above. So thank you. Yeah, I see about 10% of neuroscientists. So that is a nice mixed background. I think it's nice to have such a varied and multidisciplinary audience. Okay, so we move on. And one first question is, if you see this man with his amputated limb, he's touching the water with the artificial limb, where is the sensation of cold water happening? So apparently he does have some kind of reaction in his behavior to, yeah, it's a bit funny, but also cold, tickling, chilly. No, now I see the background question again popping up. But this is one of the questions we have to ask. Of course, there's no sensor, no sense in his artificial foot. So what is going on there in his brain then perhaps? This is more of a reminder that sensations, conscious sensations, are often naturally located in some body part where you feel them, but actually there's also something going on in the absence of the body part, a phantom limb sensation in this case, triggered by touching the cold water. And this one then, are the strawberries really red here, or is it you that is making or producing the red color? I guess you're a bit like me, that you see the strawberries in red indeed, against a sort of greenish background. And you might know the illusion because actually the strawberries, the light that is coming from the strawberries on the screen is actually a mix of wavelengths. So it's actually gray, and it is due to the surroundings, which are predominantly in green. That is the green wavelength range, that you begin to see them in red. So is this now, is this actually red that you see? Is the red really out there, or is it some result of some brain process? This is very striking. We know a little bit about color opponency in the retina, that is in the eyes, in the nervous sheet in your eyes, where especially green to red contrasts are greatly enhanced, so that indeed if you experience something gray against a very green background, then also in the brain higher up, there is a strong tendency to enhance this as a contrast. So you would indeed see red against a green background, where now the red is sort of caused by the mixture of wavelengths, and then the red wavelengths in the gray are actually enhanced. The vice versa would also work, to have a red background and then something gray in the middle, which is relatively turning green. So we know it has to do with the brain, but still it's really seems to be out there, this illusion. Then here another interesting illusion called the rotating snakes by Kitaoka. Not everybody is sensitive to it, but I myself, I see a vigorous rotation, especially at the places where you don't gaze at. So it's sort of, you have to focus where you look at, but then in the periphery, things start to really rotate quite vigorously. Now we can talk about the brain mechanisms underlying this, Perhaps if you don't see it, I could also use the example of the Kanisha triangle over here. The Pac-Man shaped kiwi pieces outline what seems to be a triangle that is also having a contour in the space in between the kiwis, actually. So let me take another question to you. Where are the illusory features here located? Is that possible answers in the external world? Is that outside yourself, really in the world, outside your body? Or B, is it in the brain, your brain? C, is it actually nowhere because it is an illusion? Or D, is it none of the above? And curious to see your answers again. Well, we see a strong tendency arising in the answers. It would be kind of nice to start a discussion on this, but that's not how the lecture is structured. Yeah, we see a very predominant answer in the brain. Okay. Well, that is also interesting because, you know, when I ask this to students and such, I would also challenge you a little bit and say, well, if a surgeon opens up your brain and looks inside, will he or she find rotating snakes in there? Yeah, this is kind of difficult to say. I mean, there are no real snakes, of course, in there, and I hope not. But then what is actually happening? So I'm going to defend the answer D actually in this lecture, none of the above, and take you on a little journey that would argue that yes, there are brain processes that underlie this illusion, but actually you do see the illusion in front of you happening on the screen. And then, yeah, what is it exactly, the process that is happening? I would argue that the brain actually forges this illusion by giving you the impression of a representation of outer space that sometimes in this case contains a little bit of misfits or misreconstructions. So we'll see how that can be substantiated. And then finally, we have the blue and white dress. Again, this was a picture that went viral on the internet, perhaps you recall, and there was a big controversy also, like whether this is actually seen as blue plus black or as white and gold. And some people appear to be able to switch. So please, can you fill in your answer? Yeah, and now we see indeed an interesting pattern emerging, because now most people have voted, and I see that about as many vote for blue and black as for white and gold, and 4% can switch. Those are very fortunate people, I think, that can do this switch. I myself, I see only blue and black. Only under very special conditions can this be manipulated. But it's interesting to see how much even split there is for the blue, black versus white and gold. So we can have a long discussion. Well, one partial explanation, at least, that you would find is here that much of this has to do with background, again, with the background of the colors, and in this case, a darker background, given the same colors and wavelengths coming off the dress, would actually tempt you to see the dress otherwise. In this case, myself, I can sort of now see why some people see it as white and gold on the right, but the white and gold people might also understand a little bit why others see it as blue and black. But this won't be the full story, because actually what you have is one picture, and some people see it in blue and black versus others who see it in white and gold, and there's only one background. So I think it also has to do with the way we interpret the picture and have different dispositions to view it. For instance, some people might say, well, this dress, the way you look at the front, is actually in the shadow relative to the background, and shadows contain more blue wavelength, so we tend to correct for that in our brain. But that's quite a complicated story to fully explain and sort out. But at least you see how subjective color vision is, how contextual it is, how much depends on the background and circumstances. Even some percepts are driven by semantics, by the meaning of an object. So now let's take a further look at what consciousness is. Can we define it sort of straight away? One definition could be sort of the thing that you lose when you fall asleep, and then you wake up in the morning, you look at the room, the bedroom, probably where you are, you hear the birds, so it's a regaining. You're suddenly back in the world, in your bedroom usually. It's a bit difficult as a straight up definition because it has some circularity in it, because now we would have to define, okay, what is a sleep? What do you mean with waking up? And then you sort of fall back on the same terms again, like a state of knowing, a state of feeling, sensing, etc. So it's not that easy to come up with a clear definition right away, but I'll come back to it later and try to convince you that there's actually a workable definition possible. We can also ask instead, how does conscious experience manifest itself? How do we recognize it in yourself or with other people or even beings? And the last poll question here is for you to say, well, you see the gorilla up there on the right, the mouse, the honeybee. There's a supercomputer here called Watson who can play a quiz, a knowledge game called Jeopardy. And there's the smartphone. The question for you is, just thinking about it, perhaps intuitively, what would you say is the lowest being in here, the lowest item that could be conscious or is probably conscious according to you? And we see patterns emerging. That's also really interesting to see. Okay, so we also see quite a few. Well, now let me wait till the voting is complete. Yes, people going up. We have 160 answers already, so 166. So yeah, you have to vote for the lowest one that you still attribute consciousness to. So yeah, interestingly, we have now 174 answers. A lot of people would still, I take it, attribute consciousness to the smartphone. That's about 45% of you in the voting. A lot of people draw the line at Watson, so the supercomputer would have some consciousness, I take it. And then quite a few draw the line at the honeybee and say, well, that still has some consciousness. But it's also interesting to discuss, and I regret that we don't really have time for it, of what criteria you use to make such judgment. So we have, let's say, criteria like the behavior, and you could look at, let's say, simple behaviors like sleeping and waking, reflexes or habits or cognition, right? The honeybee is quite known as a cognitive insect, being able to store places where a particular scent of flowers was found, nectar, pretty good learning capabilities for such a small animal. The mouse, of course, is a little easier to judge because it is a mammal, and also its brains are much more similar to the human brain than of the honeybee. For instance, the honeybee has basically these ganglia, so no real brain actually, but rather big nodes of nerve cells. Gorilla being, of course, quite close to humans, and I think most people would agree it has some kind of consciousness at least. But yeah, the computers are interesting. Indeed, quite famous scientists like Christoph Koch also attributed some consciousness to smartphones, and there we tap into the computational abilities of the computer. So how complex are the operations being conducted? Is there things like fast information processing together with memory, valuation or evaluation processes? And then Watson has this exquisite capability of answering quite complicated questions, but based on searches through knowledge databases. So there's also the internal matter, that even if beings have no human-like cortex or brain, they still might have the representational capabilities for consciousness, that is, to generate sensations and experiences. Of course, it doesn't come close to the sort of first-person experience that you have. Like, yeah, you're sure that you're not a zombie, that you're not a being without consciousness. At least I would be inclined to believe so. But others, you could always say, well, that being, I don't know, it could be an automate. It could be a being that behaves perfectly, but perhaps has no consciousness. Another fruitful way to think about the matter is to outline hallmarks of conscious experience. So what is really characteristic of conscious experience, and sort of is an inalienable feature of consciousness. We do distinguish different modes also of consciousness, and this would be classified as perception, that is of external stimuli, external environments, but also imagery. Imagery being conscious but more internally driven. Of course, you can imagine things very well with your eyes closed. And dreaming. Dreaming would be a kind of imagery, also auditory imagery, but then under less cognitive control, so more wildly associative, undirected, whereas imagery can be really controlled upon voluntary command. And then some hallmarks. Well, here in this Renoir picture, you could say, well, there's in our consciousness, our visual consciousness here, such richness of, the painted qualities of colors and shape and shadows, textures and everything, suggested movements even. So you could call this a qualitative richness, that there are just many modalities in the senses, but also the submodalities within vision, which are, color, motion, shape, etc. But then on the right, we realize that this young lady looking at the Renoir picture is always somewhere. So it's not only the painting that we experience, it's also the fact that we have a viewpoint from space onto that, and that we are always in a kind of situation when we do that. So that could be called situatedness. And I think it's also the case that we are immersed in that situation. So we're sort of always in the middle of our own experience. We're not experiencing this as a video game, we're just in the middle of that museum hall. So that's interesting. Right now, things become more multimodal because it's not only vision, there's also posture, bodily feelings, muscle tension. It's not always that prominent, but when you turn around, you will have some vestibular sensation as well. There might be audition going on, smells, and taste. So it's not, here the focus would lie on vision as the modality of attention. But actually you could say, well, this is surrounded or immersed in a much wider experience that is multimodal. We then have, for instance, integration or unity. That's well recognized as a part of conscious experience. And we mean with that actually that we have only sort of one unified experience at once, and not multiple ones in the same brain, in the same head. So integration here with the ventriloquist would be that you integrate the lip movements that are visually made by the ventriloquist and the sound he produces. You barely see his lips moving, whereas the puppet, of course, has vigorous lips movements, and you attribute the sound actually to the puppet. So in other words, the audition and vision are kind of merged into one percept, and this is happening all the time. But another form of integration would be, for instance, that both of your eyes will generate information that is not perceived as two different images, even though you have different images from each eye, but as one visual percept with depth. So there are multiple forms of integration and multiple processes to study there. Dynamics and stability as a hallmark would be that, well, on the one hand, there's William James, famous American psychologist, with his stream of consciousness. So this means a continual flow or updating of your conscious experience. There's always something changing, even time passing, memories that come back. But there's also stability in consciousness, and that is worth emphasizing, because if you, for instance, look at the Necker cube on the right, you can probably switch or learn to switch between seeing the lower right plane as the front of the cube versus the front of the cube being on the upper left. And you can sort of switch between this, but not at an arbitrary speed. There's always a certain sluggishness in the switching. So a certain constancy, a certain stickiness in the perception. And then, yeah, we realize also that if we view our environments, things are surprisingly stable or constant. For instance, maybe the laptop where you are sitting at, or another device, or the table, are all remarkably stable, because actually what happens in your visual system is that as you move your eyes and you move your head, the projection, the light patterns impinging from the table on your retina are constantly changing, really. The table for one's part is projected on a different piece of retina at the current time, whereas on the next, when you move your head, the patch of retina hit by the table is quite another one. And somehow your brain has to correct for this and take care that you actually see a stable pattern of the world and not some kind of shockingly pattern that moves about in a very rapid sequence that would give you a totally chaotic experience and make you probably nauseous. Finally, we have the point of interpretation, which is kind of an overarching point, I think. It is also called inference or intentionality, and it is the property that somehow the brain, the neurons, are able to represent information that is not pertaining to themselves. So in other words, the neural activity is about something like we see vegetables, and they're not inside our brain, but there's somehow neural activity going on that relates to these vegetables as being seen outside the brain, something we can touch. Inference meaning in Dutch gevolgtrekking. We see the duck here if we focus on the beak towards the left, with the back of the head over here. So then, if I also say, well, there's a rabbit in here, then there's the semantic systems of your brain start to basically try to match the word rabbit, the concept of rabbit, also to the image, and you discover that what was the beak could now be seen as ears, of course, and the mouth being at the right in the rabbit interpretation case. So this interpretation, plays all the time. It also has to do with our senses being, let's say, transmitting all the information they have to the brain in the form of action potentials. And that's where we're hitting the hard problem of consciousness, as David Chalmers has called it. He's a philosopher, and he said, well, a lot these days is known about the brain, about memories. Oops. Sorry about that. But basically, how do we reconcile phenomenal experience with neuronal activity? This is the impression you get from a 3D animation of how neurons are working, with the flashes, the blue flashes, being action potentials or electrical impulses that are passed down the axons. At the end of the axons, basically, could play it once more. At the end of the axons, there are synapses, which are the contact points between neurons, where plasticity takes place. This is the strengthening or weakening of synapses by which we tend to learn, which might not be the only mechanism, but it is deemed to be very important. So somehow all this neuronal wiring, all this neuronal activity would have to do with subjective experience, and that's something to be coming back towards the end of the lecture. So like I said, a big problem in studying consciousness is that we should not be tempted to think that the brain perceives the external world directly. It is totally bound to the electrical impulses that it gets from all the sense organs. On the left here you have a drawing of Vesalius, a famous anatomist from the 16th century. And without even drawing the spinal cord, he was displaying all the cranial nerves and the other nerves as they run from the belly, the gut system and the internal organs up to the brain, but also the optic nerves. And it just reminds us of the fact how dependent the brain is continuously on those nerves, plus the spinal cord. And because these electrical impulses that travel from the eyes or the inner ear to the brain, etc., the electrical impulses are all the same, basically. They all have this uniform signature. And when the brain then receives these impulses by way of afferency, by afferent input, there's basically nothing that deciphers them as saying, well, this exponential is visual, and there is no welcome sign that says, welcome to the visual cortex. So there's actually nothing that tells the brain really what the electrical impulses are about. So the problem of intentionality, of aboutness, is basically not solved at the level of nerves or senses. And the brain has to solve this itself, basically. It has to figure out, it has to make chocolate out of all these myriads of electrical impulses. So now let's take a look at other cognitive capacities related to consciousness and see what is needed. What kind of brain systems do we think are needed for consciousness? One candidate being memory. However, we had a long history already in surgery, neurosurgery, and neurology, and neuropsychology, in which patients like HM were studied. HM is the two initials for a patient that we now know as Henry Molaison. As a boy already, he suffered epilepsy and had to be operated by a surgeon called Scoville. And because there was no medicine, no pharmacology for his kind of epilepsy, it was intractable, he decided to perform an audacious surgery on the boy. He was about 23 years old at the time, because he took away the hippocampal tissue. And that's an organ that you see over there, the hippocampus. Here it's basically a seahorse-shaped structure, is what the Latin word means. So it's curled up there in the so-called medial temporal lobe, and it was removed. The surgery led to an alleviation of the epilepsy, but also HM lost a big part of his memory, at least of his, let's say, storytelling memory, the part of memory we call declarative. This is the memory you can talk about, like what you did yesterday and where you were during the first lockdown period, etc., except at home. It is a devastating disorder, this loss of long-term memory, but there was actually no question that HM would have lost his consciousness. So consciousness was still there. He had early childhood memories, that's true. He had a profound loss of recent memories. So a nurse that would come to his house, he would not recognize, even after, if she had gone for 2 minutes and came back, she would not recognize and recall that she was there. So the patients are living on an island of the present, and have very little touch with the past or the near future, because they also cannot project what's coming up next. But he was very much conscious, and there's little doubt about that. So you might talk about an impoverished memory because of the memory loss, but not an overall loss of sensations, of wakefulness. We then come to emotions, and we can also ask if they are required for consciousness. To be a little bit brief here, yes, we can also study the loss of emotionality, for instance, by lesions of the amygdala, like over here, not too far away from the hippocampus, also deep tucked away beneath the cortex is the amygdala. When lesions are made, for instance, in monkeys, also rats or mice, sometimes humans with amygdala lesions can be studied. You do see a loss of emotionality in the sense of that the organisms, the animals or humans, become, for instance, less fearful for a stimulus that would normally be eliciting fear. They have less hesitation to approach novel objects. It's also called psychic blindness, but what is really meant there is that the evaluation of stimuli is lacking or partially lost. So animals, humans also might become more indifferent and have difficulty in learning the value of particular stimuli. We see something similar of an emotional loss, but also different in patients with prefrontal damage. Some of you might have seen the movie of One Flew Over the Cuckoo's Nest, where Jack Nicholson plays a patient who undergoes a lobotomy. And this is a surgical intervention in the frontal lobes, in the prefrontal cortex, with the idea that, in the 30s and 50s, 40s of the last century, surgeons were quite desperate to sometimes wanting to alleviate psychosis or schizophrenic attacks, etc. But because there was no medicine yet, no psychopharmacology, persons like Walter Freeman Sr. Operated patients to at least try to ease them down a little bit. So with this ice pick, they went into the orbita, the eye sockets on the medial, and then wiggled to basically destroy prefrontal tissue or disconnect it from the rest of the brain. And this indeed made some patients subdued and calmer, but they also became a lot more dull and indifferent, and this tended to induce apathy. So it was a general loss of emotionality, including quieting down. But overall, this is a tragedy, a failure that was applied to too many patients. The point here, though, I want to make is that there was no general impairment of consciousness with prefrontal damage, even though there was a profound loss of emotionality. One of the features of emotionality is that we do have bodily sensations. For instance, we become angry, we might have feelings in our body about it, sweating perhaps a bit, cramp in the stomach, and those kind of things then would lead to less consciousness of those feelings. But apart from that, one can't really say that consciousness would be lost. So this tends to be dissociated as well. When we ask, well, is motor activity, is bodily activity really needed for consciousness? Then we actually also see that this is not the case. So consciousness basically survives phenomena like paralysis, even stronger locked-in syndrome, loss of limbs, like phantom limb syndromes, but also amelia. So this person here, you see, has a brain-machine interface. He became quadriplegic due to an accident, and they gave him back some control over the computer cursor on a screen by tapping off his brain signals and translating those brain signals basically into commands to move the cursor screen. He could open his emails, etc., and read things. But even stronger, people can suffer almost a complete loss of motor abilities, like in stroke. This is the former Elle magazine editor in France, Bobby, suffered from a massive stroke. He could not move anything anymore, basically, except for one eyelid. And with the help of an assistant, he was able to dictate a whole book, because with his one eyelid, he could sort of blink when the assistant would show particular arrays of letters, and he would be able to select a letter that he meant and thus compose words. And the whole book, this testified to his rich inner life and retention of consciousness. Unfortunately, after the book was published, he shortly thereafter died. The case of amelia I want to mention especially because this is the phenomenon where people are born without limbs. It's the congenital absence of limbs. But curiously enough, these people also have feelings in body parts they never had. So even they have sensations in the hands, even though they never had hands. So it's also an argument against, let's say, that memories of our previous motor movements during life could be important for consciousness. This is not always the case, certainly. So that's why I would propose that consciousness is really an internally generated process by the brain, and no interactions with the environment are absolutely needed. We're going to take a look here at what is required for consciousness. So what kind of structures in the brain are implied? And one area to look really is the visual system, the visual cortex. On the upper left here, you see basically the areas of the macaque brain, a monkey brain, that have to do with vision. And you can sort of flatten out this cortical map, the cortex that you look at, the big structure with the sulci and the gyri, and put it as a flat map over here. So V1 is the magenta patch all the way at the back, the occipital cortex. If that patch is lost, if that area is lost, people or monkeys indeed turn blind. The most interesting thing that was described, for instance, by Simir Zeki in London, was that smaller areas higher up in the system, these areas all together form a hierarchical system with V1 at the bottom, so a low area, and the higher areas being the small ones, like MT, you might see, that is middle temporal area. If you lose that area, you selectively lose the perception of visual motion. So if you take away that spot, particularly in humans, this happens also by stroke or by other lesions, you can see basically, you're not blind, but you just cannot see motion. So it's selective blindness for motion. The ballet dancer over here would be perceived as in shape and color, but the patient cannot see the continuous motion anymore. The only thing he would be able to see would be that there are changes in shape, but not like this fluid motion. A fountain with spouting water would be not perceived as moving, but rather as a sequence of different shapes that the water volume assumes. There are other such cases of essential nodes in this visual cortex system that are also very interesting, of course, very sad if you suffer from it. Like V4, this dark blue patch over here, is very important for color vision. If you lose it, you can still see everything except for color. So now you can see motion, for instance, or shapes or textures, etc., but just not colors. The world is basically gray and black and white. There are other areas, particularly in the introtemporal, the ventral stream, as we call it, that are implied in form vision and also face vision. The fusiform face area is highly specialized in humans. So like these patients with form blindness or visual agnosia of a particular type get, for instance, the question, well, I show you this white triangle. Can you now from this array pick the shape that is most similar to it? And they would pick the black circle over here. Patients can see lines, but they cannot piece it together into an object, into a shape. And so for the other things as well, it seems a really simple task. It's like almost impossible to imagine that they still can see other things, because how does that look like? Well, it's probably very fragmented in terms of lines, but no composition of lines. Another interesting deficit, but also sad, of course, is a parietal cortex lesion that's still a bit higher up, more in the yellow area here. So 7A and what we call parietal cortex, and lesion there, for instance, by stroke, tends to cause hemineglect. Now the entire portion of the visual world disappears. Hemineglect means it's half of the visual field, and it's typically on the other side of where the lesion is. So a right lesion in the right hemisphere would cause us a loss of the left visual world, as this painter Anton Rederscheid experienced. He suffered the stroke, he gradually recovered, but in the meantime he was unable to access his left visual world, be conscious of it, or act upon it. So this is a more integrative, higher area linked to visual consciousness, and this is also quite important for other senses, so somatic sensation. So now we have sort of an impression of some of the areas important for vision. I don't really have time to go into the other senses, but they are equally interesting: audition, smell, etc. I'd like to switch a bit to the topic of what consciousness could be good for. Like, is it useful? Does it have a function, or is it just there as a sort of epiphenomenon we might enjoy? Of course, we also suffer pain consciously, but overall, a lot of people would say, well, we enjoy our lives. What I want to show here is the assertion that consciousness indeed does have a clear function. And we look at a frog because, as you'll see, the frog isn't always able to do what we are able to do as humans. And noting that the frog has almost no cortex, no hersenschors, as we say in Dutch, but it still has organs to process visual stimuli. So there could be a difference here. I think there is a strong difference between processing visual stimuli and reacting to them versus consciousness as this multimodal, rich, situational phenomenon. See for yourself. Okay. The point being that the traitor is also really caught at the end. But the other point being that the frog is really not able to respond very well to the concept of the smartphone. Of course, he never saw a smartphone, is not familiar with it. But the contention is also that frogs are not really acting in a context-sensitive way. So they have this form appearing, this crawling of the ant, and what studies indicate is that there are, let's say, bug detectors in this special part of the brain that he does have, so he can react to the visual stimulus. But there's very little evidence that he would integrate the fake ant into the wider environment and appreciates the context in that respect. And so what I propose and also develop in a book from 2015 and the recent Dutch book is that we have to deal with two action systems. One is much more related to reflexes and habits. That is simple stimulus response behavior, single stimuli upon which you can react very quickly, versus complex decisions, which are made due to a lot of planning and determining what your goal is, what steps you have to take to reach the goal. So one example of a reflex is here. The hot plate, accidentally you touch it, you rapidly withdraw your hand, and that's reflexive. You basically don't need consciousness for it. It happens faster than you think. You're not going to think, oh, well, let me decide whether I'm going to pull my hand back. That's not how it works. You might wonder afterwards, like, I now have a burnt hand. What do I do? Where's the cold water to flush it? And what was the cause of this stupid action I made? Perhaps I wasn't paying attention to the heating plate. But that's all talk afterwards, and the contrast is thus made with complex decision making. And here the argument is that we live in the present, but there's a whole set of widely branching possibilities into the future of possible actions we could make, and action A or action B could lead to a wild variety of further actions. And to determine the best actions across the whole pathway towards a goal, we need a lot of information, basically. So how do goals come to be selected? Well, that would be, I would argue, because you want to have in the first place this rich survey of your situation. So you must have not only the information about the ant crawling somewhere in your field, but also where the ant is, where it is located, does it have depth information, etc. Do I smell anything? Well, not in case of the digital ant, of course. So this survey, this sort of instantaneous survey, about the situation, including your body state, is quite crucial in conjunction, of course, with memory. And so if we see Memphis Depay here fighting with his German opponent, might be a bit of a contentious example also for Maastricht, which is close to the borders of Belgium and Germany. But you know, even as a soccer player here, you have to think very carefully: how is my body positioned? Where's the goal of the opponent or the goal of myself? You see the green, that means green grass, soccer field, particular rules that apply there for your behavior. So this all must be taken into account in order to decide how to work on this ball, whether to kick it and hit the goal of the opponent or make a defensive action. So the definition of consciousness then is actually to say, well, you need consciousness for future decision making, and thereby it gives you a multimodal immersive survey of the situation you're in, with your body sensations included. So that's basically the function. Also, it's not the same as behavior, but you could say it's subserving this decision-making process. Then a few words about mechanisms. So how far are we with modeling conscious systems, or at least perceptual systems? Well, I'm not going to claim here that we do have a conscious computer. I also think that Watson and the iPhone are not conscious, but this is another discussion. One powerful idea, I think, to begin with the approach of computational models of perception is to say what perception actually is, and that is indeed the inference about the causes of sensory input, a notion that stems from Helmholtz in the 19th century. He already said, well, look, it's not so much that our perception is giving you the pattern of photons on your retina. What the brain is really aiming to do is to try to guess what's causing that pattern of photons on the retina. So it is about trying to reconstruct or see how the real world horse is looking as it causes these sensory patterns. And the computational model, the computer model, is now to say, well, we have systems in the brain, the higher areas, that generate representations or predictions, and they try to predict what's going on at that lower level of sensory inputs. That is the image, the input layer. This could be compared to the retina, or perhaps the next highest station in the brain, that is the thalamus. But now the predictions are being generated, and they're sent downwards to these lower layers by the higher layers, and then a comparison is made with the actual sensory input. So in other words, how good is the prediction? Is it actually showing a big difference? Well, in that case, one talks about an error that is being generated, a discrepancy signal, and that is fed forward from the lower to the higher areas. So let's say from V1 to these higher areas. And based on the error, then one learns and improves one's predictions, one's inferences about what's going on. So the concept of representation here is very close to the concept of prediction. And the way this, you can imagine this is that all these gray little squares are neurons with, in black and white, their activity levels. So they're not depicting the horse in any way. So that's why I think the rotating snakes are also not in your brain. But we call this a latent representation, because a valid latent representation can lead to the sort of reconstruction of the original cause. So you can actually get back to the original horse picture if there was a good prediction made of that. And we think this roughly mimics how things are happening in the brain, because there's also in the brain a progression from this lower visual area V1 to the higher areas like infratemporal cortex IT and backwards. So the projections are both forward to the higher areas and backwards. And this is coupled to an increase in the complexity of the kind of visual stimuli you can process. Here we have then a step back to philosophy, basically, because in the end we have to ask, well, can you really explain everything about consciousness by computation, by computer-like processes, let's say? Because computations, of course, are in the end all numerical. And I've also said, well, there's this qualitative aspect about conscious experience, and by definition, qualitative is not quantitative, or at least it's not only quantitative. So we do have to address really what's fundamentally going on. And I would say, well, the computations are important, but not everything there is to explain about it. There's more to it. Descartes in the 17th century, of course, is known for his dualism, the position that basically there are two radically different substances, the mind or the soul and the body, which does raise the issue of how they communicate or connect, because he thought, well, with our free will in the mind, we can actually activate our body parts. So there must be a communication also the other way around from the senses back to the mind. And that's, yeah, probably the biggest nag, the biggest problem here, that people haven't just not been able to figure out how this communication would work, because it would mean that something immaterial, the mind, would impinge on something material or physical, and that would violate things like the law of conservation of energy in physics. One should really have an exquisitely good story to declare such a violation. What I'm much more charmed by is the philosophy of Spinoza. He proposed, as you might know, dual aspect monism. So this holds that basically mind and body are aspects of the same entity, the same unitary phenomenon. And you might recall how historically Spinoza was expelled already at a young age, excommunicated from the Jewish community in Amsterdam, the Portuguese synagogue. A later version of the building you see here, and here's the bridge across the Houtgracht, across which he presumably walked after being excommunicated. There's actually these days a big fuss about whether this excommunication should still hold, but some people think it should be upheld, actually. Anyway, this mind-brain unity might be attractive, but how could it work? This was not a topic that Spinoza could address, really, because he had his philosophy, but there was almost zero neuroscience knowledge at the time. The way I've been working on this is to say, well, on the one hand, we have, of course, the neurons with their synapses in the brain, their axons, but as network models also have shown, it is actually possible to build, wait a minute, I'm going to stop this movie. To build out of simple neurons, you build networks that have emergent properties. That is, they are properties that you can't recognize at the individual cell level, because they are doing more than the sum of the individual parts. So like this simple depicting of the number 4 here by these gray valued neurons would already be a pattern property that the single neurons cannot display. And indeed, people like Hopfield have shown by modeling that such simple shapes can be stored in the network, but it can also be recalled. Also in our predictive coding work that you see here on the right, we see how handwritten digits are being recalled by the network. This is the reconstruction step in the predictive coding. And it's also emergent because it depends on the collaboration of all these layers, input layers, higher areas, etc. So the contention is actually that besides the, let's say, the neural level of implementation that you see here at the bottom right, this is the hardware of the neurons and the wetware, the synapses, the gooey stuff, let's say, the lipids, the membranes. Above that level, you have the level of computation, that is pattern storage, etc., pattern recognition. But above this, going to even more complicated networks, the assertion is that we finally reach the phenomenal level, which transcends the computational level. Well, this is the concept, but it needs to be worked out in more detail at the level of neural systems. And this is where I propose the concept of multi-level representations. It basically means that what we're trying to do is have these little predictions going on as hypotheses at the very bottom of the scheme. So these are, when you see a scene, a little hypothesis about the shape of an object, like this piece of cheese over here. But these are all separate attributes of the same visual object. So we also need, at a higher aggregate level, a meta-network level, a representation of the hypothesis of what the visual object is, like this entire piece of cheese with its shape, its texture, perhaps its motion, color, etc. So that needs to be integrated there. And from there, you could even go higher into hypotheses or representations of multimodal objects. That is, that the smell becomes integrated, perhaps the sounds in the scene. The integration with the further spatial environment needs to occur. And we are beginning to see, let's say, the neural equivalents of this, the ensembles at the level of groups of cells, how they unite into things like the visual system with all its attribute properties. But also this anatomical scheme here is a multimodal network that unifies across the senses. So here we come at the end, and I look forward to the questions. In summary, I would say, well, just to answer the question posed by the lecture title, no, we can't really say that there is a code that can be fixed in a way or can be cracked. Consciousness is rather a continuous updating, a dynamic process of representing and predicting things. It is about best guess representations we build, and so the rotating snakes are part of this huge representation, a simulacrum that our brain is actually making as we experience external reality. It's sometimes quite a topsy-turvy view, an upside-down view, but I think the evidence is quite consistent with this view, but also with older philosophy, for instance, of Immanuel Kant. So the definition of consciousness I've tried to defend is that this is a spatially encompassing contextual thing with its rich multimodal detail, both of the body and environment, with a clear function, namely to enable you to act in the world and deliberate and make complex decisions. We do know bits and pieces, as I said, about what parts of the brain are connected to visual experience or also auditory. And in the end, then we have this, more non-reductionist view. It's not the same as the monism of Spinoza, because basically Spinoza said, well, matter and mind are inseparably connected. They always go together. Whereas here, what we have is a view that says, well, it does depend all on matter, but it needs to be organized in the right fashion, namely in the form of an alive, waking brain. And no consciousness is expected to be really present throughout nature, not even in complex physical systems, unless they have this representational ability. So thanks for your attention. I say, if you're interested in one of the books, please visit one of your Maastricht bookstores, like the Dominikaner Church, which has a beautiful setting. Thanks for your attention.
Will the recent published Dutch book be translated in English?
We're working on that. I hope there's a decision on that soon, and we're having a conversation with various publishers there. So
okay, I hope so too.
Yeah.
Very insightful already, and I'm sure when we read the book, we dive into it much more. In the chat, there's also a tip for a book. Hagar tells us that she thinks Jablonka has a great book on specific theory of the evolution of consciousness. Are you familiar with this book, Cyriel?
Yes, somewhat. It's a very interesting book if you want to follow the development of consciousness and relation cognitive capabilities throughout time across the animal kingdom. And I think Jablonka with Ginsburg links it very much to learning abilities. And it's somewhat akin to my view, because I think they also emphasize the contextual learning aspects. So not just a simple stimulus response learning, as in the case of the frog. So yes, this is very much recommended.
And this is one by Bart Monen. Who asked, would an octopus having multiple brains also have multiple consciousness? I'm not sure if you're an expert on this, but...
Well, I do have a special interest in octopus, but I'm certainly not a specialist. So first of all, I would say it's hard to say whether an octopus is conscious. But there are certainly scientists who defend this view, like Godfrey Smith. You might know some of his books on octopus. Indeed, well, I would say he has multiple ganglia, so they're basically big nodes with nerve cells, some of which indeed control individual arms of the octopus. But then he also has these big cerebral ganglia that are tightly connected. So it might be the case that if he has consciousness, that he has one. What it would be like to have a sort of micro consciousness of one arm, well, I'm not going to exclude it, but it's a little bit hard to imagine. So would basically not say that he has multiple brains, but rather has multiple ganglia that control it. Yeah, I think the evidence on the octopus consciousness is a bit controversial. Godfrey Smith makes the case. He says, for instance, that it's a bit anecdotal, but an octopus was sitting in a tank, a water tank in captivity, and an animal caretaker would feed the octopus by feeding him usually a living shrimp that the octopus would be very fond of. And someday, actually, the animal caretaker ran out of live shrimp, so he took defrosted shrimps from the fridge. And he says, well, the animal caretaker threw the dead shrimp in the tank where the octopus was sitting. And the octopus held the dead shrimp. He didn't eat it, maybe he sniffed or so, but the animal caretaker would walk on towards the other tanks, and the octopus would sit there with the dead shrimp in one of its tentacles. And only when the animal caretaker returned, the dead shrimp would be not eaten but released into the sink, as if the octopus was sort of signaling, I don't like your food, and I want my live shrimp again. Well, this is a bit all anthropomorphic. However, it sort of illustrates something about the intelligence and planning capability of the animal. And because I also make the link to planning capabilities, there might be something there. Yeah. So very interesting question. Then we have Maarten
Ottenhoff. Is there a measurable definition of consciousness? As far as I'm aware, or the only real manifestation of consciousness is ourselves experiencing our own consciousness. And how do you define loss of consciousness and requirement of consciousness without the ability to measure it, aside from subjective or anecdotal interpretations of someone else's consciousness?
Yes. Okay.
Do you get the question?
Well, yeah, there are many questions.
A measurable definition, so to say.
Yeah. Very good question. Very complex question. Many questions in one, actually, I think. There is a lot of debate about this in the field. One group led by Giulio Tononi says that they have a measurable definition of consciousness, which basically relates to information complexity in a system. That is how much differentiation of information you have and how much integration. So in short, a big neural network should have both varied levels of activity, coding different things, but all the elements also have to be doing something with each other, that is being integrated. Yeah, I don't particularly agree with that theory, but it is an interesting one. There are some other, let's say, approaches, not like a single measurable thing. We have proposed for animal consciousness, for instance, looking at the theory I tried to briefly explain today, is what are the derived measures, what are the consequences of having such a rich multimodal representation, and how would that be expressed? So you can actually measure in animals also things like goal-directed behavior, susceptibility to illusions. I could show you a video of animals that really respond quite specifically to these rotating snakes, not as if it was just a simple picture. things like the complexity of visuospatial behavior is could be a measure. So we actually arrive at about 6 criteria there, that if you combine them, you get kind of a scale of consciousness, saying, well, if you study rodents, for instance, mice or rats, then all these 6 criteria point to some degree of consciousness. And also for some birds, this is the case. Also, episodic memory would be a derived measure. So they're not, let's say, exact measures or exact definitions, but workable approaches, I would say. A third approach is this is more about computers and robots, to look at their internal representational capabilities. So that's what we also try to do with animals or robots, is to derive from the internal complex operations how much information is represented there. And this can be quantified, but it's still in its infancy, I have to say. Yeah, then there are clinical judgments of consciousness, like EEG patterns measured from the scalp with EEG electrodes can also give doctors an indication of how much conscious there might be. Yeah, quite indirect. But yeah.
Then how do you see the consciousness of a person with a dissociative identity disorder? Because especially integration and unity does not really apply in this case.
Yeah, very smart question. Yeah. I think what I might add to integration and unity is that this applies to any one moment, but that the sort of consciousness can change over time. It has been described in people with dissociative identity disorder, so they tend to adopt multiple personalities, often due to a traumatic history. Let's say the famous case and book is Sybil, with, I think she had 24 personalities or so. What you do see in EEG measurements is that the physiology of the brain switches along with the identity assumed. There have been even reports of one identity being a blind person and the other one not. And you could see this by the EEG measurements from the visual cortex, that the signals were reflecting, let's say, not seeing, or a state of blindness. But I would maintain that even in that case, there's still integration and unity, because within that altered personality, there's only one experience happening at the same time. So it's probably more a matter of, let's say, the frontal areas being disrupted that tell the areas at the back, the sensory cortices, how to behave and what to do. But still, yeah, you're right. It is a heavy switch. Yet I would maintain that within the assumed personality, there's still integration going on. Complex question, yeah, complex
Yes.
answer.
If we define consciousness by its hallmarks, would it be like describing an orange by its features and describing these features without ever describing the orange? Does it lead us anywhere to go in such a circular way, or is it just the only thing that we can do?
Well, you say without ever describing the orange. That's not the intention, to leave that out of the hallmarks. So one of the hallmarks, the way I see it, was to say, well, one hallmark is this multimodal qualitative richness. In the case of seeing an orange, the orange color would certainly be part of it. It would be very prominent in that way. So it's not denying, but you might say, well, but you're not really catching the orange specifically in your description. It's just a general hallmark. This is true. Yeah, in my book, sort of in the last chapter or so, there is the discussion, right? Because I come up with a scheme of multi-level representations and say, well, this particular philosophical position is maintaining the phenomena, the phenomenology of seeing the orange, but it juxtaposes it to the neural correlates. And now you might say, well, yeah, but if you do that, then you throw away the baby with the bathwater. You're throwing away the orange color. Yeah, in a way, I think there's going to be an experiential gap in the sense that when you look at neurons, you will never see the orange. But it is also a little bit of matter of accepting this, because you find this in many physics theories as well, that it's sort of beyond the stretch of our imagination. Like we cannot also really imagine the Big Bang happening, because it's not a simple explosion. Space itself came into existence with the Big Bang. So that's really, I think, impossible or very hard to imagine. And I think we have something similar here, that the exact finger on the transition from orange to neuron cannot be pinpointed all the way. Yeah.
Thank you. Do you believe in the concept of free will, or would you consider some form of determinism to be more plausible?
Yes, also a very good question. I didn't talk about it because it is actually in the Dutch book also a chapter on free will. But I think the first question to ask is free with respect to what? Do you mean free with respect to our environment, so that we are autonomous individuals? Or do you mean free from material processes, that we sort of, our mind transcends matter in being independent from brain matter? The latter I don't think is the case. I think there's this correlation and mapping and causality, but there's a great degree of stochasticity in brain processes. That is that, you know, if you look at the way that neurons are governed in their firing, it's very stochastic. There are these little protein channels that open up for ions, and that is very much a process of chance. The only problem is that if you aggregate all this into big populations of neurons, then it becomes more deterministic again. I think what it comes down to, as explained in the book, is to say, well, the brain usually, when you have the feeling that you make a free choice, is going through such a complicated process of nonlinear processing with many loops and feedbacks that it becomes impossible for an external agent to predict what you're going to do. So in the end, it's largely deterministic, I think. It does have a component of, let's say, thermal noise, etc. But it's so complex, let's say it's so close to deterministic chaos that it's almost impossible to predict what you will do in the end. So that means, yeah. Okay, well, let's go to the next question. Yeah.
Yes. When someone is, for example, psychotic, does he or she have consciousness?
Yes, I believe the answer should be yes here. It is a state of course, often coupled with fear, but also hallucinations that we generally see as misrepresentations happening. Hallucinations, for instance, would be, of course, experiences of things which aren't really there. It's not really imagination or imagery in the sense that people cannot control it. It sort of forces images upon you, or voices that are heard. But they are conceived of as a strong dominance of this internal representational system without much correction by external stimuli. This can also go to the cognitive level, of where you, for instance, you hear things. There is a misattribution in the sense that you say, well, this, whatever I hear is not coming from myself. It's not some interior monologue, but I attribute it to an external agent. So the source attribution is wrong. But all of this still resorts under consciousness, even though it's a diseased state. Yes. Yeah.
Okay. Is it maybe possible that you move your camera a little bit? But I think the questions are in one corner and you're moving to that corner, and then we hardly see your mouth anymore. Sorry for that.
Yeah, I wasn't planning to hide away behind the questions, but yeah.
It was also nice to see that your shoulder disappears in the background now and then when you move backwards a bit.
Oh, yeah.
Virtual background. So what is real here? Oscar Katwijk, would it be possible to map out an entire human as a big complex algorithm, corrected for all socioeconomic, etc. factors, And if so, would it be possible to make a conscious computer? And if not, would it be sufficient to make computers act as if they're conscious perfectly?
Yeah, it's another big one.
You do talk about AI and the developments in computers, right? And when it comes to consciousness,
Yeah. The problem I have with a term like algorithm is that it's basically a set of computing rules. Like you give it an input, you input it into the computer, and then the rules are released on it to spit out an output. I think you could certainly describe aspects of human behavior that way, because behavior can be nicely quantified. What we're lacking here, I also try to point it out a little bit, is that algorithms as such are only computational and don't have ability as yet to generate anything like qualitative properties. So they could process, let's say, wavelength information in the form of numbers, but actually not generate something like color perception. I do think, however, that this is classical algorithms, and that if we know enough about predictive coding and its extensions into these more high-level meta-networks, that there is no barrier for computers not being able to mimic that. So in the end, I think it should be possible to make hardware operated by the right rules to actually emulate consciousness. Entire humans would also have bodies with kidneys and so on. So that could be mimicked or at least simulated. It's a bit harder to make it for real. So would it be possible to make a conscious computer? I think in the end, yes, but my way is to study the brain more first, a lot, and then turn to computer models to slowly improve them. So the models I showed are, I think, a beginning. There are other people in the field who go along with this, like Carl Friston, Anil Seth, but we're still a very long way from a conscious computer, I think, which might be good, because if we're making conscious drones or other lethal weapons, can we still shoot them down, or do we have to think about their rights of being freed from pain, etc.? So what to do if computers really suffer pain? Then we're in trouble, I think. So we better make a good set of agreements on that.
But you are in favor of developments that way, that computers become more like our brain?
Well, mainly in the sense to just understand the brain and to help people with disorders of consciousness or sensory loss. So to help people that have turned blind see again, or hearing, etc., repairing stroke consequences. But I think in general, for the defense or military industry, one has to also make clear rules about this. It is a potentially very dangerous development. Then you ask, if not, would it be sufficient to make computers act as if they're conscious perfectly? So in other words, to emulate their behaviors. This already would be very interesting, and it might be the case that at some point we will not be able to say, well, this computer is conscious based on its internal operations. Mm-hmm. But if it's part of a robot that exhibits like perfectly natural, intelligent behavior, like orcas do, or monkeys or dogs, then we as humans would judge them to be conscious. That might just be the case. I don't know whether you've seen the movie Ex Machina, but that illustrates the case that a human is falling in love with a female robot and is just so convinced that she's human and conscious that, the trap opens for him. Yeah.
Next one. Couldn't or doesn't a lot of complex decision making already take place unconsciously? Multisensory integration could also happen unconsciously.
Interesting point. That's certainly the case, that a lot of decision making can happen unconsciously. That is, you see that in like the advertisement effects. Often people cannot explain their behavior rationally. It seems to be given by indeed subconscious tendencies, feelings. But I'm actually not arguing with that, at least that there are unconscious biases on complex decision making. But I would maintain that complex decision making generally involves processes like deliberation and planning and thinking what you're going to do, thinking about alternatives, so counterfactual thinking, and that this would be very hard to do without any consciousness. So imagine that you go to a beach site, right? And then you have to decide, am I going to the bar and have a drink or into the sea swimming? But you're unconscious, right? You're not experiencing anything, not the temperature of the sand, not the wind, nothing. So there's, yeah, that's very hard to do, unless maybe you're a very simple organism just with reflexes. So that's more the point. I'm not arguing with the unconscious biases that we have. Now, multisensory integration does happen unconsciously, but this is studied in the form of that, let's say, an auditory stimulus helps to detect something visually. Like you would hear, maybe you see something in the distance, and then when the dog starts barking, you sort of recognize, hey, well, this is a dog, and I actually was seeing that dog already. What I mean with multisensory integration is more complicated in the sense that it's not only about such cue integration, but also about the experiencing the distinction between the senses. So actually having the qualities that make the senses so different. That's, I think, a very basic process, but something that is also characteristic of conscious systems. Yeah.
Thank you. A new question came to the top. On topic of consciousness requiring emotions, I was exposed to a definition in computer science by which emotions are simply probabilistic modes of action. For example, if someone is afraid, there's a low probability to laugh, but high probability to freeze or become defensive. One could see how that can be implemented with code. If one day a machine, let's say in a body with the senses similar to the senses of the human body, can display emotions, which may even be superior in complexity compared to a human, would you consider it conscious? If not, what else would be missing in your option or in your opinion? Sorry. So emotions into a robot, so to say, is that the trick?
Yeah, what I find a little bit difficult, but I appreciate the question very much, is the conflation of consciousness with behavior. And we see dissociations really between that. So you might know the phenomenon of blindsight. I was planning to talk, but the time was lacking. It is when people are actually turned blind because, for instance, their visual cortex is lesioned heavily. But when you present stimuli in the blind part of the visual field, the blindness could also be partial, as in a scotoma, then people are still able to behaviorally guess more correctly than chance. So they almost refuse to participate in these tests because they say, well, it's no use showing me stimuli because I can't see them anyway. But if you ask them, they guess above correct. And it means that a lot of behavior is also possible, like the other question said, without consciousness, and that there's some kind of bypass route around consciousness that still guides our behaviors. So also here we can imagine all kinds of emotional responses, but without consciousness, in the way of freezing. Yeah, sure, we can build a robot that freezes or displays some kind of defensive behavior. It might become quite complex or superior. If you have enough programming options, it will do that. But yeah, I think what is lacking in the end is you need a convincing case in the way that the robots, would have to tell about its experiences as humans would do, or would have to give other behavioral evidence of having emotions. I think emotions here is interesting, but computer science definition, I think what we understand in psychology and neuroscience of emotions is that there is a stimulus, sort of that triggers the emotion. Then there is a reaction, and that reaction is in the motor sense, so motor preparation indeed, or overt motor behavior, but also valuation, that is, an emotion is either nice or not so nice, it's nasty, fearful versus happiness, etc. And this is also expressed in autonomous body reactions, which lead to indeed to feelings like feeling sweaty, feeling cramped, angry, etc. So I think it is a much richer phenomenon than just about probabilities of displaying particular behavior. Yeah.
Okay. Next one, is a newborn conscious, not being aware of its own existence? If not, when do they become so?
Yeah. Very interesting question. Also, well, I do make a distinction, at least, between self-consciousness, which would also be being aware of your own existence, and the more raw sensory consciousness that I talked about. So there are cases where people are consciousness in the sense I mean, that is, they have conscious sensations, but they don't know that it's them who has the sensations. These are, some particular drug experiences like ketamine. People sometimes report that they don't feel themselves. They're part of the environment. They melt into the surroundings. But there are also disease cases where this happens. But to the newborn, it's hard to say. We think that based on somewhat older children, for instance, who are born blind by congenital cataract. This is they have a star in their eyes, a cataract that makes them blind. But you can repair this, and in developing countries like used to be India, there were a lot of people aided by these cataract operations. So they got artificial lenses implanted, and then they could see. So it mimics a little bit the process that newborns must be going through. And what it shows is basically the newborns learn to see. So in the end, in the beginning, I'm sorry, you have like color blobs, vague forms. They don't really group into objects. What the congenital cataract people show is that they learn to distinguish objects, for instance, because a bicycle starts moving, and then they see that the shadow is not so much attached or part of the bicycle. The shadow disappears if the bike turns around the corner. So there's a lot of experience involved, but is there some basic consciousness? Yeah, that could be. Yeah, there could well be consciousness of pain, for instance, if you look at the expressions of newborns. Yeah.
And maybe these things already develop in the mother when the child is not born yet, right?
Yes, yeah, indeed. Yeah, difficult topic. It's one other thing is self-consciousness, how it arises. There's some studies on that would be around the age of 2, about 2.5, where children learn to recognize themselves in the mirror. And if I move my arm, then the mirror image will also move, and that's caused by me. It's caused by something that we call myself. So yeah, also very interesting to study. Yeah.
One of the last questions. It's we're past the time of 9:30, so I hope you still have some energy, Professor
Sure.
Pennartz. Is there anything in ancient Eastern philosophy that corresponds to your findings and thoughts about consciousness?
Yeah, I love this question. Indeed, there are some thoughts in Buddhism, as I'm not a specialist on it, but people tell me that Buddhism is very much inclined also to, well, we didn't talk about the self very much, about self-consciousness, but one concept is that also the self is a construct, in that there's like no fixed brain region where the self is, and distortions of the self also show that what we call the self is also amenable to hallucinations. This is illustrated by things like out-of-body illusions, also encountering duplicates of yourself, people that experience jumping from one body to the body of a doppelganger, so a body double, so to say. So there's lots to say that the self is very complex, but it's basically also a construct by the brain, including the feeling of body ownership. So there are really neurological disorders where people feel that part of their own body doesn't belong to themselves. They want to kick the leg out of bed that belongs to them. It comes down to saying, well, the self in that sense is not some kind of homunculus or entity in the brain or a subpart of the mind, but rather, yeah, it is not objectively existent. Actually, it's more a story that we make up to explain the way we experience the world. And yeah, that seems to be akin to some Buddhist philosophies and perhaps related ones. The mind-brain unity, I think, is also a concept entertained in at least some streams of Eastern philosophy. So yeah, this is interesting to pursue. Yeah.
Yeah. Okay, so the last one. Justice Jonas Erker, thanks for the workshop or the lecture. Would you say only physical system to be conscious or also simulated ones?
Yeah. This is also debated in the field. Yeah. So one often heard argument is that if you build a computer that does forecasting of the weather, it will never feel anything wet. So you can predict rain and simulate it, but it will never rain inside the computer, and the computer will not experience any wetness. The problem with that argument is that our brain is a little bit like that, huh? The brain, you might know the Chinese room argument of John Searle. He basically says, well, computers cannot be conscious because all they do is process, let's say, Chinese inputs. If you don't know Chinese, then it's very hard to understand. And the outputs are also in Chinese, but in between there's just a rule book that is the algorithm. It governs the conversion of inputs to outputs. But if you think about the brain, then as I showed, that processing in the brain is also dependent on action potentials. So that's electrical impulses. It's actually very much like digits, 0 and 1 flowing through the brain. And so I don't think that the original argument against simulations hold. And I think that one has to say, if the computer mimics the brain closely enough in its inference and representational processes, yeah, there's nothing that would prohibit the possibility of consciousness. Yeah, in other words, of course, a simulation always has a hardware component to it, and that could ensure that yeah, the real experience is eventually emulated. Yeah, but you're right. We don't know a lot about the exact architectures that you need. Yeah.
Well, thank you very much. I'd like to finish. Thank you, Professor Cyriel Pennartz. Looking forward to reading your book. I didn't, not yet, I'm sorry. I did read the review, so I got curious. I have it on my, and next to my bed, I would say, or at least on the table. I hope everybody enjoyed this lecture. Like said, it has been recorded, so if you want to look back, send us an email. We can send you the link to watch it back. We're keeping the chat open for another minute to see if people really enjoyed it, to say goodbye and thank you. Sorry we didn't make it through all the questions. There's still 19 left. It's a little bit too much. Okay. Wish you a good night, and I thank you very much, Professor Pennartz.
Yeah, thanks again, and also for the wonderful questions of everybody. Yeah, it's really an enjoyable event. So yeah, thanks for joining.